In a previous video, we broke down how to read whole callouts using the imperial system. You know, good old freedom units. But what about metric? Most of the world outside the US uses the metric system, and yeah, that means engineers aren't dealing with inches or threads per inch. They're using millimeters. So instead of measuring speed in hamburgers per bald eagle, it's kilometers per hour, and instead of 5/8, 11 threads per inch. UNC, you're looking at something like this. Let's break that down. M means it's a metric thread. Easy enough. 16 is the nominal diameter, so the outside diameter of the thread is 16 millimeters. 1.5 is the pitch, meaning the distance between threads is 1.5 millimeters. Unlike the imperial system, which tells you how many threads per inch, the metric system just tells you how far apart they are. So millimeters is how much the bolt moves forward with each full turn. Now let's talk tolerances. This part can look confusing at first. In 5G, 6G, we actually have two tolerances. 5G is for the pitch diameter. That's the imaginary cylinder, where the threads actually make contact and carry the load. 6G is for the major diameter, or the crest. That's the very top of the threads. Each of these has a number and a letter. The number, like 5 or 6, is the tolerance grade. A lower number means a tighter tolerance and higher precision. The letter, G in this case, is the tolerance position, which tells you how that tolerance zone sits relative to the nominal size. Lowercase letters are used for external threads, like bolts, and uppercase letters like H are for internal threads, like holes or nuts. So if you're tapping a hole to match this bolt, you'll see something like M16 by 1.56H on the drawing. And finally, LH stands for left-hand thread. Most threads are right-hand by default, tighten clockwise. So you only include LH if you want it to tighten counterclockwise. Metric callouts might look weird if you're used to the imperial system, but they actually give you a lot of detailed info once you know how to read them. Now you know how to read metric hole callouts in mechanical blueprints. Save this for later and follow for more tips on machining and engineering.